Use finite approximation to find the area under the parabola x squared and above the x-axis between x's 1 and x's 3 using the midpoint of each subinterval with 4 rectangles of equal width. So we are working here. Our function is f of x defined by x squared on the closed interval are such that x is greater than or equal to 1, less than or equal to 3. And we know we want to use 4 rectangles. So we are going to let n be equal to 4, and we'll redefine our subinterval, or interval here, a to b, or x naught, x sub n, as the closed interval from 1 to 3. So now that we have the number of rectangles in our interval, let's go ahead and find the width. So we want 4 rectangles of equal width. So we know that the width is defined as the length of the interval, so x sub n minus x naught, all divided by the number of rectangles. So we have 3 minus 1 all over 4, which leaves us with 2/4, which simplifies, of course, to 1/2. So therefore, the width of each subinterval is going to be 1/2 unit long. So we now can use this width to subdivide the interval. And we want to subdivide our interval 1 to 3 into 4 subintervals. So starting with our first endpoint here, we have 1, and we want to think to ourselves, all right, 1 plus 1/2 is going to leave us with 3/2. So there is our first subinterval. The next subinterval again starts at that previous interval's endpoint, and we think to ourselves, okay, 3/2 plus 1/2 is 4/2 or 2. So then our third subinterval is going to be 2, and we think, okay, 2 plus 1/2, or 4/2 plus 1/2 leaves us with 5/2. And last but not least, again, our fourth subinterval here starts at the previous interval's endpoint, and we think to ourselves, all right, 5/2 plus the width, 1/2, leaves us with 6/2 or 3, which is what we've needed to find. So we know, again, this is a great way to check our math to make sure we're heading in the right direction. So these are our 4 subintervals. And here we want to use the midpoint of each subinterval to find the height. So let's make a little love note here to ourselves. To find the midpoint of each of these subintervals, so to find the midpoint of each one of these subintervals, we're going to need to take the sum of the endpoints and divide it by 2. So that will give you the midpoint for each individual subinterval. So let's go ahead and we'll calculate these midpoints for each one of our subintervals and then use it to find the height and sketch our graph. So we want to find the midpoints. So in our first subinterval, we have 1, 2, 3/2, and we need that first midpoint. So it's going to be 1 plus 3/2 divided by 2. So in the numerator, again, in that common denominator, we end up with 5/2 divided by 2, which we, of course, know that's equivalent to saying 5/2. If we think about 2 in the denominator is 2 over 1, we multiply by the reciprocal of that fraction, which gives us a midpoint at 5/4. Of course, as you get more comfortable with this, you don't have to show as much detail, but it's always good to show your work to get started. So in our second subinterval, we have Our second midpoint is going to be 3 halves plus 2, or you can think about that as 4 halves, all divided by 2. So that's 7 halves divided by 2, which gives us 7/4. So that's our second midpoint. Our third midpoint in the third subinterval from 2 to 5 halves. Our third midpoint is going to be 2 plus 5 halves, or again, we can think of this as 4 halves plus 5 halves, all divided by 2. So we have 9 halves divided by 2, which gives us 9/4. And last but not least here, our fourth and final subinterval, 5 halves to 3. We need that midpoint. So our fourth midpoint will be 5 halves plus 3. We could think about 3 as 6 halves all over 2. So we have 11 halves divided by 2, which leaves us with 11/4. So these are the midpoints that we're going to need to use now to calculate the height, and then we can see our graph. So here we go. So let's find the heights. So again, your height is the y value here, and our beautiful function is the parabola, or x squared. So in the subinterval 1 to 3 halves, we're using that midpoint. So we are calculating f at the midpoint 5/4. So we have 5/4 squared, which leaves us with 25/16. And no decimals. We want to use improper fractions here. So we have 3 halves to 2 is our second subinterval. So I have y is equal to f of the second midpoint, which is 7/4. And we're squaring this. Right? So we have 7/4 squared. So it's 49/16. Our third interval is from 2 to 5 halves. And we are calculating the height using the midpoint of that subinterval, which we found to be 9/4. So we have 9/4 squared, which gives us 81/16. And last but not least, we have that subinterval 5 halves to 3. And here we found that our midpoint is 11/4. So we are evaluating the function at 11/4. So I have 11/4 squared, which gives us 121/16. Phew! So we've got all of the heights that we're going to need using those midpoints. And so now we're ready to start approximating the area. And then just so that we can really appreciate what we're doing, let's actually think of this graph real quick. Especially if you're asked to sketch a graph of this on an exam or a quiz. Wink, wink. So here is our coordinate plane. We've got our y-axis and the x-axis. So we'll start with a 1 by 1 scale on x. We'll say 1, 2, 3. And then since we have our function is a parabola, I'll do a 2 by 2 scale on y. So we'll say there's 2, 4, 6, 8, and 10. So I'm just going to use our whole numbers here to sketch this graph to get us started, and then we'll think about our subintervals. So we know when x is 1, y is about 1, or is 1, not about. When x is 2, we know that y is 4. And then when x is 3, y is 9. So here is the portion of the parabola that we are concerned with. This is y is equal to x squared. We have our endpoints. So that this is the region here that above the x-axis that we're trying to approximate the area for. And don't forget that we are dividing this into those 4 subintervals. So here is 3 halves, here is 5 halves. But we're using the midpoint of each interval here to find the height. So from that midpoint, we can go up until we hit our graph and create that triangle. Excuse me, that rectangle. So there's your first rectangle in interval 1. Here is the second rectangle in interval number 2. Here is the third rectangle in that interval number 3. And last but not least, there is our fourth rectangle in that fourth interval. So these are the values that we just calculated. I'll label them 1, 2, 3, 4. So there's our corresponding points on the graph. So let's go ahead now and find or approximate this area. Give ourselves a tiny bit more room. So we are approximating the area using the midpoint rule. So our area is going to be approximately equal to the width, again, multiplied by the sum of the heights using the midpoints. So this is going to be equal to the width of each interval we know is 1/2. And now we want to take the sum of those heights. So we have f of 5/4, which we found to be 25/16, plus the height at 7/4, which we found to be 49/16, plus the height at 9/4, which we found to be 81/16, plus, last but not least, we have the height at 11/4, which we found to be 121/16. Whew! So here we go. Let's give ourselves more room. So we did get lucky here in that we do have a common denominator for all of these fractions. So we can simply add their numerators. So we have 1/2 multiplied by, this is going to be 276 divided by 16. So we can simplify a little bit here. Thank goodness. We know 16 is 4 times 4, and 276 is 4 times 69. So we can simplify those 4s. We can cancel those 4s out. And let's see, we are now left with, we have 1/2 multiplied by 69/4. So we can state our final answer now and say that this area, by the midpoint rule, is approximately equal to 69/8, and this is square units. And so this is our beautiful final answer for the approximation of the area using the midpoint rule.